Let's discuss a simple electric circuit powered by a battery. Chemical reactions inside a battery produce a certain potential difference of voltage across the battery, say 6 volts. This voltage produces electric current in the circuit connected to its terminals. One terminal is positive and the other negative. Which is not important here. The current in the light bulb depends on voltage produced by the battery and the resistance of the light bulb. So it's important to distinguish among voltage, current, and resistance. Voltage is energy per charge, a sort of electric pressure, measured in units joules per coulomb, which we call volts, symbol capital V. To say a battery is 6 volts means that every coulomb of charge passing through the battery is given 6 joules of energy. Current is the flow of charge per second, usually electrons, produced by voltage. Current is measured in coulombs per second, which we name amperes, or for short, amps. The symbol for amps is a capital A. Suppose the current is 3 amps. Carrying 3 amps means that every second 3 coulombs of charge flow through the wire. Energized electrons flow from the battery through the circuit where all that energy is dissipated and back through the battery again to be re-energized. If a break occurs anywhere along the circuit pathway, current ceases. The direction of current in this simple circuit is not important. Some terminology. Charge flows through a bulb, so we say there's current in a bulb. Voltage is established across a bulb. Voltage doesn't flow, charge flows. Resistance is a property of the substance through which the electric charge flows. Very little resistance in copper and a lot in rubber or plastic. Electric resistance is measured in ohms. The standard abbreviation for the ohm is Greek letter omega. Like the song, Ohm, Ohm on the Rain. Resistance is where energy is converted to heat and light. In this single bulb circuit, most all the resistance is in the bulb's filament. Here we're considering an incandescent bulb, less common now but still around. Here's the symbol for resistance. We ignore all resistance in the connecting wires because compared with filament resistance in the bulb, the resistance offered by the wires and battery interior is negligible. We also ignore the effects of temperature on bulb filament resistance. A bit of history. Early in the 19th century, a German scientist and teacher, Georg Ohm, discovered a relationship between current, voltage, and resistance. He found that the amount of current in a wire is equal to the voltage across the wire divided by its resistance. This is Ohm's law. Current equals voltage per resistance, where I represents current, V represents voltage, and R represents resistance. An example with simple numbers tells us that if a battery is 6 volts and the resistance of a light bulb is 2 ohms, then in accord with this law, the flow of electrons, the current, is 3 amps. 3 amps means that 3 coulombs of charge per second flow through the circuit and through the bulb. That's why the bulb lights up. Got to say here that 2 ohms is a very low value of resistance for a light bulb, but we say 2 ohms here to keep the numbers simple. If you understand all this, you can answer this question. If we replace the 6-volt battery with a 12-volter, what will be the current in the same bulb? Did you say 6 amps? That's right. Twice the voltage gives twice the current for the same resistance, 6 amps. More energy is given to the bulb and it glows brighter. Let's introduce a second bulb, this one with twice the resistance, 4 ohms. Now the total circuit resistance is 2 ohms plus 4 ohms equals 6 ohms. The 12 volts supplied by the battery is now across 6 ohms. What's the current in the circuit? In accord with Ohm's law, 12 volts divided by 6 ohms equals 2 amps. So the battery supplies 2 amps to each bulb. This is a series circuit because the same amount of charge flows each second through both bulbs, through one and through the other. the current in each bulb is the same 2 amps. An interesting question. When the switch is turned on, which bulb glows first? Turns out they both glow at once. That's because the battery sets up an electric field throughout the circuit, which travels at the speed of light. So current is established in all parts of the circuit simultaneously. We'll learn later that the electrons that make up current already exist in the wires of the circuit. The electrons in the bulb filament, for example, are already there. The electric field nudges them all at once, just as the command "forward march" by a drill sergeant sets soldiers in a line stepping all at once. More about this later. I want to leave you with a question. If we connect a third bulb in our series circuit, say one with 4 ohms of resistance, how will this affect the current supplied by the battery? Until next time, good energy.